So the next speaker is Stephen, our colleague from Nigeria. A couple words about him. He's a leader of Java user group in Lagos. So he's used to organizing similar events and speaking in them. And from the practice, he's the one who asks questions when no one else has those. And he's the one first to share things with others about things. And sharing is not his main trait. He's also a certified developer. And he's working daily with Springboot and AWS. And he has prepared us a presentation about Spring Restful web services and that application deployment to AWS ECS Fargate. Stephen, the floor is yours.
Hello. Thank you very much, Nereus. Okay, so welcome everybody to the session for Spring RESTful Web Service and AWS ECS. So Nereus has talked quite a lot about me. So that's just me in the picture with my brand new Telesoftware smile when I joined in January. So if you to Spring Boot, if you are new to Spring Boot, or if you are a developer looking for easier or a cost-effective way to deploy applications to the cloud, then this session is going to interest you. So what we'll be doing today is I'll actually be building a RESTful web service with Spring Boot. Technically, I won't be building it. I have the code on GitLab, so I'll just pull the code down and do some explanations on it. And in the end, I'll be deploying to Amazon Elastic Container Service, ECS, using the Fargate launch type option. So what I'll be using for this session is I'll be using IntelliJ as my IDE. I'll also be using Git to clone the repository down to my local. Then I'll be using Java 17, but if you have Java 8 on your machine, it's also fine. Then also Docker installed, though not necessary. Then because I'll be pushing to AWS, I need an AWS account. It is free to open. And also I have AWS CLI installed. So if you don't have AWS CLI on your machine, there is a link in the repository on how to download and install it. So this session will be more of demo, and they'll be in two phases. So the first phase is I'm going to demo for you a Spring Boot application that exposes to endpoints. So the first endpoint will just to save employee records to a database, and the second endpoint will be to list all the employee records from the database. Then the second phase will be to deploy the application to ECS. So I'll be building the image, pushing the image to ECR, then also create ECS tags, then finally run the ECS tags. So let's get started. So the first thing I'll do is to jump off to GitLab. I already have the code repository open. This link URL will be shared with you if you want it. And it's a public repository, so I'm going to do a Git clone. So copy the clone command, then jump off to my IDE, then get from VCS, paste in my URL, then clone. So that's the basic reason I'll be using. I need to have Git installed. So I have cloned the repository to my local. So here you can see the README. So you can actually go through it to see some basic instructions on how to run, build, and publish the image. So typically, a Spring Boot application will have the structure. You have your pom.xml file, where you have the metadata for your project, and you have the dependencies for your project, and you also have the plugins defined. So here I have some Maven wrapper files because of Maven is the build tool I'm using in this project. Then I go into the source directory. I have a main and a test. So this test will be added for you automatically by Spring Boot. Then here I have my ECS demo application. So decorated with the Spring Boot application. And also this is my main class. So if you're a Java programmer, you know that the main class is the entry point for your application. So basically, your Spring Boot application, because of it's going to be performing CRUD functionality, you want to organize your packages into like the MVC structure. So here I have the entity package. So this package is really going to contain your plain old Java objects, right, that will eventually become a record in your database table. Your repository package, right, is going to contain classes or interfaces that will handle the mechanism for interacting with your database. And also your service package is going to contain your business logic classes, and your controller will contain classes that will expose your endpoints. So I'm going to open my entity package. Here is my employee class because of I will be saving employee records into the database. So this is a plain old Java object with 4 attributes. So I have decorated it with the @entity annotation. This annotation tells Spring Data JPA that this is going to be a record in the database, and this as ID annotation tells Spring Data JPA that this is going to be the primary key for this particular record. Now, off to my repository. Yeah, so all you need to do in your repository is to extend the JPA repository, right? And a lot of things come to you out of the box. So with this, there are a couple of methods that you can just use without writing them. There's a way you can write your method names, and Spring Boot is going to provide the implementation for you. So also on my service here, okay, I have my employee service. So this is where the business logic, yeah, I have just 2 business logic, the logic to create the employee and the logic to get all employees. So typically, because of the employee registry knows how to interact with the database, you want to auto-wire the employee repository into your employee service, right? Then you delegate the methods to save and to find all to the employee repository. So to my controllers, here I have 2 methods here exposing 2 endpoints, right? So a REST controller decoration to tell Spring Boot that this is going to be a REST controller, a request mapping endpoint, annotation to show the paths that leads to this controller. And also I have to auto-wire the employee service here because of I'll be delegating the responsibility to create and get all to the employee service, which in turn delegates it to the employee repository. So this particular method will be called whenever a post request is sent to this path. And the post request is going to get a request body with an employee object. So all it does is to call the create employee method from the employee service. And also, when this path at all is called on a GET request, right? This particular method is called, and the employee service calls the GET employee method. So I could just run this application right now. Okay, I could run it from here or from here either. So close this up. And great. So my application has started on port 8080. So you can see Tomcat started. So because of in Spring Boot, right, we have a lot of dependencies that we could add. I added the Spring Data Web, and that Spring Data Web comes in with an embedded Tomcat. So we have Tomcats started at port 8080. So what it means is that if I go to my Postman, I already have it open, then I hit localhost port 8080/employee/all. This is going to call the get method, right, which I have defined in my controller. So if I should click a send, and of course, there is no employee in my database. So what I'm going to do now, I'm going to go to the post requests. So here, localhost 8080/employee, a post request, and the request body, right? Remember, the employee has an ID, first name, last name, and an department. So if I should send this, okay, it has been saved. Okay, I will just send another one, give it an ID of 4. This time around, the first name of Steve and the last name of last something, also in the IT department, and I send it, returns. So come back to the get all endpoint and assign your request. So you can see now we have the 2 employee records coming out from our database. So basically, that's it with the Spring Boot side, and we have been able to save the employee record to a database, and we've been able to list all the employee records from the database. So now the next thing we're going to be doing is to deploy the same application to AWS ECS. So go back to my IDE, and what I'm going to do next, I'm going to come to the Maven tab here, and I'm going to select a Maven Go Spring Boot run image. So now, what does this particular Maven Go do? I could have typed it on the terminal, but since I'm using the IDE, I could just run it directly from here. So what it does is that it builds an image, a Docker image for us. So this is one of the advantages you get when you use Spring Boot. So Spring Boot comes with a variety of tools that you can use for development. So with just a single click here now, I will just, as you can see, it tries to do the compilation to ensure that everything is fine. Then eventually, it begins to build an image. Okay, so the build is successful, but yeah, I missed something. Yeah, I did not change my image name. Okay, so basically, that is what that particular command is going to do. But because of I want to push the image to the Elastic Container Registry, I need to up to Amazon right now and create a registry. So I'm going to jump off to Amazon. So when you get to Amazon, you log in and you could just come to this bar and search for ECR. So ECR is the Elastic Container Registry. So if you click on that, it's going to bring you down to this page. So I don't have any repository yet. So I click Get Started. So create a repository, a public repository. I'll just call this Spring ECS because I'm doing Spring and ECS today. So I'm going to leave every other option like default. You could make it scan your image if you want to, add encryption sets if you want to, but because it's just a demo purpose, I'm just going to create repository. Okay, filled with the repository error name. Okay, I've seen this before. Maybe I need to refresh this page. Let's do it again. Spring ECS. Leave everything as default. Okay, great. So now we have created a repository. So we need to be able to push our image down to this repository. So what I'm going to do is just to copy this URL from here and up to my IDE, right? Jump off to my pom.xml, and I go to my Spring Boot my Maven plugin. So here I need to configure my Maven plugin to push the image to this particular repository and this name whenever I run the command. So if initially it pushed it to Docker IO library, blah, blah, blah. So right now it's going to push it down to this point. So I'm going to run that again. Maven, Springboot image, build image rather. So it's running, checking that everything is fine. Everything is fine. So it's building the image now. Okay. So it's going to do some pulling. Okay. Okay, maybe this may take a couple of seconds to do. So, but however, while this is going on, I think I would just also talk a little bit about Spring Boot because of at this point I'll be jumping over to AWS. So why did I have to use Spring Boot? So Spring Boot is actually a Java framework that allows you to build Java applications quite easily and quite fast. And another reason you want to use Spring Boot is because of Spring Boot is the most popular Java framework. So what it means is that if you run into issues, you could simply jump off to Google or jump off to Stack Overflow and type in probably challenges you're having, and you can be very sure that you will be able to get a solution. Okay, so now we can see that the image has been built successfully, right? So the next thing I'm going to do, I'm just going to copy this bit. Copy these bits and jump off to my terminal and just run a simple docker push command. Paste it here. And great. So now it's been pushing. So I need to mention at this point that I already have AWS CLI installed and configured. So when I run this docker push command, right, it automatically grabs my AWS login credential. So if you don't have your AWS CLI installed and configured, if you run the docker push command with that particular image name, it's not going to work. So you want to make sure that you have the AWS CLI configured before you run this. So now, okay, it's going to take a while. So I'm going to jump off to my slides and talk a little bit about ECS. So there's some buzzwords I'm going to use going forward now because I'm talking about AWS ECS. Okay, I'm out of the Spring Boot section now. So I have talked about the Elastic Container Registry ECR. So ECR is just basically a repository to store our container image. So what we are doing right now, the image that was built, I'm trying to push it to the container registry. So I've also mentioned a lot about ECS, is the Elastic Container Service. So basically, it's just an orchestration service that allows you to deploy and manage your containerized application. And also, we will be using Fargate. So ECS, right, has two launch type or launch options. So one of them is Fargate and the other one is ET2 instance. So we'll be using Fargate in this demo purpose. And what Fargate does is that it allows you to run your containers without having to manage server instances or clusters. So all you do is to manage containers and nothing more. So ECS clusters, so clusters are just going to be, in this case, are just going to be region-specific group of containers. So we're going to have a group of containers that will deploy to a specific region, and that makes up our cluster. So we also have ECS tags definition. So this allows you to specify which Docker image to use, which port to use or to expose, the amount of CPU, and also the memory to be allocated to your container. So in this case, everything we're doing, we are managing those containers, our images, the ports, and the CPU and the memories. So you do that in your ECS tags definition. which actually, if you write it by hand, is just a JSON file. So an ECS tags is an instance of an ECS tags definition. So when you write your ECS tags definition in a JSON file, then you create ECS tags from your ECS tags definition. And also, we'll be talking a little about ECS services. So the ECS service is actually, you use that to maintain a desired number of tags, right? So the idea behind the service is this: I could specify that I want, say, 5 tags running from this particular tags definition. So if I specify that, now Fargate will always ensure that as at any given point in time, those 5 instances must always be running. If for any reason one of these instances tags goes down, the containers goes down, Fargate is going to spin them back up. So whenever, for production purpose, right, you always want to define your ECS services. So let's jump back to, yes, to my terminal, and I can see that the image has been pushed to the repository. Jump off back to my repository and click on it. So we can see that the image has been pushed some 3 minutes ago. So what I'll just need from this bit is to copy the URL, because of how I'm going to be needing it when defining my tags. So it has been copied. So the next step is to create an ECS cluster. So to do that, I'll just hop off to the search bar and look for ECS. So ECS comes, Elastic Container Service, click on it, and takes me to the landing page. So I have ECS and ECR. Okay, we've done ECR, EKS. So I just want to click on clusters. So Amazon has done kind of a good job here to make you get a cluster up and running. So I'm going to so easily click on get started. So the first thing I want to do is to define my container. Yeah, these are some predefined containers here, but I'm going to go for the custom. Click on configure. I'm going to give my container name Spring ECS, and the image. Remember I told you in the tags definition, yeah, you define the image to use, you define the ports, and here memory limit, I'll just leave it basic, like because of this just a demo, just leave it soft limit, and image is good, then click update. Great, so I'm done with my container definition. So now, yeah, my tags definition here. So everything looks good. There is already a network mode selected for me. This is the permission that will be used to run my tags, compatibility is Fargate, and of course the memory and the tags CPU. So what I could just do here is to just edit the name. I'll just call it Spring ECS. Then everything looks good, and click on save. So on the next button. So the next thing is to define my service. Okay, Spring ECS service has been defined for me. I could decide to increase the number of desired tags if I want to, but because of this is just for demonstration, I'll just make it 1, and everything looks good. So let's just jump off. And here, finally, my cluster. So you could see even from this particular diagram we have here, the core, we have the container, which we have defined, the tags, and now the service. So finally, we get to the cluster. I'll just call it Spring ECS. Spring ECS, and click, leave everything also as default, and click next. So I get to a page just to review. If I want to edit, I could do that. But I think everything looks good, and I will click on create. Okay, so now this is going to take some, let's say less than a minute though. So here we can see that the ECS resources are being created. So 3 resources will be created for me: the cluster, right? In the cluster, then a tags definition, so, and the service. So when the service is complete, I'm going to have a single tags that is being deployed into my cluster. So alongside, there are some other services that will be created for me because those services are needed for this particular ECS container I'm running. So first of all, there's going to be a log group. So here, if I have several containers, all these containers, they are logs, they're going to be like a log stream, and each of the log streams will make up the log group. So it's basically a CloudWatch service. If I should click on it to take me to a CloudWatch page, let me just click on it so you see what I'm talking about. So it's basically a CloudWatch page, and the log stream is being provisioned. So it's not yet complete yet. So once it's complete, you're going to see it there. So here is also the CloudFormation stack. So all the resources that are needed to make this work are also configured here. And here, this is the VPC, that is the virtual private network here. So here on my VPC, I'm going to have 2 subnets and also a security group. And right now, I can see that all my tasks are complete and everything looks good. So I can go and view the service. Okay, so here is just, I can see that my cluster is active, just one tag definition. Desired count is 1 because I just had 1 task in my service, and running count is 1, meaning I have 1 task running in my cluster. And of course, the launch type is Fargate. So this is my service details. I can click on this place to see the tasks. So right now, I have just 1 task running in my cluster, Fargate launch type. So if I should click on this, so I have more details about it. And on my network tab, I can see I have a private IP and a public IP, and this is what I've been looking for. So I copy my public IP and I jump off to Postman. So my endpoints, here I have localhost 8080, so it's no longer on localhost, it's running on my public IP. And I send it. Okay, going over the network, and of course, we don't have anything in any records in the database right now. So what I'm going to do, I'm just going to jump off to the get command, get request rather, and send it again. Okay, Steve last this time around. Let me give him an ID of 1 and send it. Saved in the database. Then let's just give James Bond. Give him an ID of 2. Let's put him in the maybe accounts department and send it. Okay, so we have 2 records on the database. So if I should come back and do a get all, great. So we have 2 records in the database. So what we've been able to do right now is that particular Spring Boot application, I have been able to deploy it to ECS using the Fargate launch type. So let me jump back to my slides now and let's talk about the finishing notes. So so I'll be talking about the pros of ECS Fargate. So first of all, with Fargate, you don't need to manage infrastructure. So all you need to do is to manage your containers, right? You define which image to build your container from. You define the ports, you define the amount of CPU and the amount of memory, and also other specific container things. So with Fargate, all you just do is manage containers. It takes away from you all the tasks of having to manage your instances, managing whatever other things that have to run on your instances. And also you can see that it was so easy to launch. And if I need to scale it, I could just jump over here and edit it and just increase. Okay, jump over to my cluster and come somewhere here, service, and I try to increase the number of the tax year to 2, and that's it. So now, another advantage of ECS Fargate is that the costs. So you can see I put lower costs maybe. So why is this so? The reason is because of comparing ECS Fargate and the EC2 launch type, right? There is a certain threshold that you're going to run your ECS Fargate, then you're going to have a cost-effective, it's the entire system will be cost-effective, right? I use the right language for that. But if you're going to run your ECS Fargate, right, for a longer period of time, then there is a possibility that it's going to cost you more. So going to the cons, right? So if you are a user that you need to have greater control over your containers, then of course you may not want to use ECS Fargate. You also may want to use ECS EC2 launch type. And of course, if you're going to be running your containers for a prolonged period of time, then there's a higher chance that you're going to incur higher costs than when you run EC2 instances. So basically, that's it. So I think we could take some questions now.
Of course. Thank you, Stephen, for an extremely detailed presentation. And everyone can learn right now and launch their startup with the promises for a new unicorn. And the public is very active with questions. There's so many, I don't know whether I should ask everything right now. But let's start from the bottom, I guess. And then the first question would be, what would be the alternative to ECS without using the cloud at all?
An alternative to ECS without using the cloud at all, meaning you want to run it on premise.
Most likely, yes.
They want to use Kubernetes on premise.
Yes, that I agree. Kubernetes, Docker Swarm, or other orchestrators that allow you to run containers. Yeah, that would work. And then related question is, and also cryptic a bit, so pay attention. I've once been told that AWS Fargate is for ECS and EKS, what AWS Lambda is for EC2. For example, serverless versus non-serverless. Would you agree with this analogy?
Okay, for Fargate, I have an understanding about that, but for Lambdas, I basically have not used Lambdas much, but I wouldn't, really, I can't give you a direct answer to that because I cannot tell you so much about Lambdas right now.
Yeah, so let me help you a bit here to understand. So ECS and EKS are alternatives, and Fargate is built on top of ECS. So that's not entirely different things than you would say I'm firing up a machine on the cloud and I'm spinning up a service in the cloud. So they are not so different as would be serverless versus non-serverless. Yes, moving on. So then on how AWS ECS differ from AWS Lambda is, do you want to answer that or you would defer that to me?
So I actually defer the Lambda part to you.
Okay, agree. So differences are in whether you manage the servers that runs the service or not. So in terms of Fargate, that is built on ECS, that's more like Lambdas. But if you look at the ECS as a container service, then Lambdas would be way lighter thing to run and way quicker to spawn in new instances and scale. So that would be the main differences. Other questions? Yeah, controversial one. Can you use AWS CDK to deploy ECS? If so, why don't you?
Okay, so this demo was just it's just to show you that of course how ECS can be used, right? But if you want, you can go ahead to use CDK to define your infrastructure.
Yeah, yeah. And this demonstration as a Spring Boot application was quite basic, and then the quite basic introduction into using AWS services. And so you don't have to learn Spring Boot and the things that Pius did with AWS CDK and TypeScript. So this way shows that you can learn the keywords easier and then upgrade yourself to AWS CDK, whether with TypeScript or with plain Java. And I guess that's it for now. If maybe there are questions from the audience on the topic, no. Then other questions we can answer at the end of the talk or in the networking part.